Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Yesterday, we looked at tangents. Today, we have two objectives. Number one is to show you that if two chords in the same circle are the same length, they're the same distance from the center. And number two, to show you the relationship between the product of the pieces of two chords that intersect in a circle. In example 1, we're going to look at this circle with a diameter of 10. If it has a diameter of 10, then it has a radius of 5, and all three of these lines are radii. We know the length of the chords 8. Each of these pieces are half of that. So each one of these pieces, half of 8. This piece here, you better know this Pythagorean triple, is going to be 3. That's a 3, 4, 5 right triangle. These chords, both 8, are both 3 from the center. In this picture, we're going to examine intersecting chords. To help us in this picture, we're going to put in two lines. This line and this line, creating in the picture kind of a bow tie sort of shape. I know these are vertical angles, so they're equal. I know that this angle down here intersects this arc. Let me show you. This angle here intersects this arc. This angle here, this one, intersects exactly the same arc. That means that this angle down here and this angle up here are the same size because they're both inscribed angles and they intersect the same arc. That means that these two triangles, while not congruent, are similar. And that means the pieces are in the same ratio. Similar triangles are in the same ratio. So if we look at labeling this A, B, C, D, E. In triangle 1, let's look at piece AD. In triangle 2, over here, AD is going to correspond to BD. In triangle 1, DE this piece is going to correspond to DC here. Let's say that one more time. AD, this piece in triangle 1 corresponds to, in triangle 2, this piece. So they occupy the same position. In triangle 1, AD, this piece, is to DE, this piece, as BD is to DC, this piece. That gives us this proportion. In a proportion, we can cross multiply. When we do, we get that relationship. That relationship shows that the product AD times DC, the product of the pieces of that chord equals the product of DE and BD, the pieces of that chord. So the product of the pieces of one chord equals the product of the pieces of the other chord. In this example, we can find this piece here using that relationship. Product of the pieces of this chord will equal the product of the pieces of that chord. To solve that, we can divide both sides by 9. And discover that x is 2. Three times 6 equals 2 times 9. In this example, we're still looking for x, and we know that the product of these two pieces, 6 and 4, equals the product of these two pieces, 3 times x. To solve this, we'll divide both sides by 3, and discover x is 8. Quick check. 6 times 4 is 24. 3 times 8, 24. The product of the pieces of one chord equals the product of the pieces of the other chord. In example 2, once again, I've asked for you to use this. The product of the pieces of one chord equals the product of the pieces of the other. In this example, 7 times 4 equals 14 times x. Divide both sides by 14. and you discover x is 2. In review, this lesson taught you that equal chords are equidistant from the center of the circle. And it taught you the product of the pieces of one chord equals the product of the pieces of an intersecting chord. Tomorrow, we're going to look at the pieces of two secants, because there's a relationship between these. And the relationship between a secant and a tangent. We can discover how long those pieces are, and that's what we'll do tomorrow. Been a great audience. We'll see you tomorrow.